So I'd like to tell everybody a bit about Charity Engine. First, what is Charity Engine? A bit about us, a bit about the service, the infrastructure we're running, and then I'll talk a bit about some of the public science that we've been doing since the last BOINC workshop. So we describe Charity Engine as a crowdsourced cloud service. So we use volunteer compute resources for commercial use as a cloud service, and we use this to generate revenue for charities. So the sort of basic value proposition to the volunteers is fundamentally different than with BOINC, where people volunteer to support scientific research. Here they're volunteering to generate revenue for, so to speak, brick and mortar charities. But additionally, we allocate a portion of our capacity to public interest research. Towards that end, we're well over 1 billion hours donated so far. And as I'll get to later, we have a lot more capacity we can donate. So more to come on that point. We've been pretty successful at recruiting resources with a sort of a different message to volunteers. We've got over 1 million CPU cores. We say the GPU number is a bit fuzzy because they're harder for us to use, and we have about 2 petabytes of usable distributed storage. In terms of overview of the service itself, we provision these resources in what we call cloud standard instance types so that they're familiar to users. So basically, the majority of our instance types, we can do things by special arrangements, but basically 2 CPUs and either 2 or 4 gigs of RAM. We've benchmarked those against AWS instances so people have a sense of what they're going to get compared to the kinds of resources that they use in regular cloud services. You can run on Charity Engine software basically in any Docker container subject to the specifications working within the instance types that we have available. We've also developed some support for proprietary software. It's the first proprietary publisher is Wolfram, so you can run your Wolfram engine or Mathematica code directly on Charity Engine, and hopefully we'll grow that library of proprietary apps as well. In terms of using the compute resources, we have some standard interfaces. There's an API and a CLI. We have a lot of people we work with use the CLI. They use something like New Parallel, so it just looks like you have 100,000 CPU cores, under your desk or something. There's a web UI. Honestly, people are coming to us for batch computing, so the web UI isn't terribly useful, except that it lets you keep track of how much work you've done, status of work, things like this. A neat thing that's happened in the context of our work with Wolfram is there's an integration directly within Wolfram language. So if you're writing your Wolfram language code, you can just write into the code to send the computations off to Charity Engine and collect the results back and integrate them directly into your Wolfram language application. We developed a smart contract implementation so you can provision and use compute resources through an Ethereum smart contract. There's a lot of super cool things that could be done with this, but nobody's ever used it. So one thing that's important in this vision of sort of cloud services is that scheduling basically is included. So for a scientist or other kind of user, you just point to your input files and your Docker container, your application container, just give a command line, and then provisioning and scheduling, all of this happens automatically. So the person who wants to do their work, just they can do their work. Just give us the raw materials, we'll compute it, give you back the results. I mentioned we have some distributed storage functionality, and this one of the things you can do is we can send the computations to the data. The core of that is in BOINC, but we've built a fair amount around that. So if you're working with a very big data set, it's really more efficient to move the computations to the data than to be moving the data all over the place. And we've got some preliminary support for building pipelines and workflows. So for instance, drug discovery project we're running called Find Bio has a really kind of cool pipeline where we start with just chemical descriptors and protein sequences, literally text strings. And there's a modeling pipeline that models molecules and proteins. Each of those is a separate application. The outputs of the modeling are fed into a simulation application, and the outputs of all of those things go into a machine learning service that generates predictions. And all of this is automated, so we can really begin to do some really interesting things, basically. In terms of public science, I guess this is probably a bit small, but we're donating quite a lot to quite a large number of BOINC projects. It's a decent portion of the billion plus CPU hours that we've donated. We have quite a lot more capacity we could share. So if anybody needs more capacity, let us know. We tend not to be running GPU apps because this will be a topic for next week. But the noise of the fans and whatnot seems to lead people to drop out faster. And we're a bit slow to support other people's VirtualBox applications for similar reasons of user impact. So again, that's a topic we'll talk about. But generally, if you have a BOINC project and you need CPU resources, drop me a line. We also, though, are supporting non-BOINC projects for research, much along the lines that both David and Warren were talking about, where it's both complicated. A lot of people who might want to do research don't have the depth and diversity of expertise to build and maintain a BOINC project. There's challenges and risks for volunteer recruitment, and in many cases, those are out of line with the needs, for instance, of somebody whose compute needs are finite or time limited. So anyhow, we've been supporting a number of people who have computational research they want to do. One being Stephen Wolfram, who's been really great to work with. He's interested in a math problem, Emil Post's problem of tags. So they've been running quite a lot of compute on Charity Engine. This quote from him was shortly after we started, actually, on that point, not that many devices even. We've helped science fiction author Greg Egan, who's interested in permutations. He has a project, super permutations, and we've lent them, I think, something like 50 million CPU hours, and they've got some very nice results from that. We've been supporting a researcher, Darren Lee, who's participating in Conway's Game of Life, giving them compute resources, and Darren has racked up quite a lot of milestone discoveries in the Conway Game of Life context. In fact, here you see basically Darren's output running on Charity Engine compared to all the other users of Conway's Game of Life combined. In other project, this is one that we're running. We did a demo with CDC, the Center for Disease Control, running a biosurveillance service. So this is what we built with them, where they have metagenomics data from environmental samples that get submitted every day. And we're screening each environmental sample to identify pathogens of concern to the CDC. And so this is an example of the dashboard from the application where they can get a flag on if pathogens of concern are present in any of the samples that they're collecting. And then lastly, in this sort of whirlwind tour, just to kind of keep us on schedule, we recently got a grant from the UK Research and Innovation Fund to explore energy use in distributed computing networks. So we're just getting underway with that, but quite interested to see what we can learn, and in particular, what approaches we can develop to deploy jobs in ways that optimize the energy use of the devices in the network. So that's the whirlwind tour. Again, if anybody needs compute resources for a large project or a small one, for research that has a BOINC project, we can attach hosts, or doesn't, we can get you started. It's quite easy. You just need to have your application in a Docker container, and we're ready to go. So that's the whirlwind tour of Charity Engine. If there's any questions, definitely let me know.